A student reached out to me in my other video for help on trigonometry. So this video is for you. It's going to be a little bit different from my other videos. I'm not only going to just do the questions, but I'm also going to explain all of my working out. So this video would be a little bit longer than my other ones. I was sent 4 pages of trig and I'm going to divide it into 2 videos. So this video will be 2 pages, all multiple choice, and then there will be a second part that I will do a little bit later. There's a lot to get through, so let's get started. Question 1. Tan squared theta over sec theta plus 1 equals sec theta is equal to what? Let me write it out first. Okay. The first thing that I notice is the tan squared theta. If there's a squared, there is probably a trig identity that goes with it. So let's get our trig identities up. Alright. So tan squared theta plus 1 is equal to sec squared theta. Therefore, we can substitute this tan squared theta with sec squared theta minus 1. Let's do that. Okay, now I want to combine these 2 fractions. So I'm going to multiply this one. I need the same denominator. So I'm going to multiply the sec theta with sec theta plus 1 on sec theta plus 1. So I'm essentially multiplying by the 1. So I'm not changing the fundamental value of sec theta. Therefore, we get okay, so we have sec squared theta plus sec squared all over sec theta plus 1. Now that they have the same denominator, I can combine these 2 fractions. Minus 1 minus sec squared theta minus sec theta all over sec theta plus 1. Now positive sec squared theta and a negative sec squared theta cancels out. What we do have is minus sec theta minus 1 all over sec theta plus 1. Now we can take out the common factor of negative 1 at the numerator. So we have sec theta plus 1 all over sec theta plus 1. These 2 cancels and we're going to have negative 1. Okay, let's look at our answers. A, negative 1. On top of this, what you can do is you can instead of doing it the algebraic way, you can, since this is a multiple choice, just substitute in a value for theta and then see what it equals. So I'm going to change color to blue. So let's say that theta is, let's choose a random angle, let's say 72 degrees. I always like to choose random angles rather than anything like 90 degrees or 60 degrees or 30 degrees, just because I want a more accurate result. So let's get our calculator and just substitute in theta for 72 degrees in the question and see what we get. We should get negative 1, but let's see. So we have a fraction, tan 72 degrees squared all over sec is 1 over cos 72 degrees plus 1 minus 1 over cos 72 degrees. And we got minus 1, which is great. So if this was an exam, I wouldn't even bother doing it the algebraic way. I would just substitute in a value for theta, put it in my calculator, and see what it equals to. Now, you do have to be good at putting numbers in calculators. I do know a lot of students that cannot use the calculator correctly. So if you are one of those, then I would suggest you to do it both ways. Maybe the first time round, just substitute it in your calculator and see what you get. And if you don't get any of these values, and you're just tempted to say none of these, I would say that's a bit sus if you don't get any of the values. So maybe try to do it the algebraic way and see what you get. You should get the same both ways. Anyway, let's go to number 2. Alright, number 2. We have sine theta minus 2 sine cubed theta all over 2 cos cubed theta minus cos theta. Let me write that down. Alright, first thing that I notice is common factors. The numerator has a common sine theta as a factor. So I'm just going to take that out, and the denominator has a cos theta as a common factor. Okay. Now, next thing I notice is that there's squared, yet again. So 1 minus 2 sine squared theta sounds like a trig property. So let me get that up. There it is. 1 minus 2 sine squared theta is the same as cos 2 theta. So I'm going to substitute that in. Cos 2 theta. And then 2 cos squared theta minus 1 is also cos 2 theta. So that's convenient. Cos 2 theta. They are common factors of both the numerator and denominator, so they can be crossed out. And sine theta on cos theta is tan theta. Let me see. Tan theta b. Now to check, again, let's put theta as some random degree, random angle, and we're going to go with 72 degrees for everything in this paper. And put 72 degrees as theta in the question. We have sine 72 minus 2 times sine 72 degrees cubed all over 2 cos 72 degrees cubed minus cos 72 degrees. Okay, so we have 3.0776835 ... And we're going to put it in the answer that we have, which is tan 72 degrees. 3.0776835 ... There you go, they're equal. So therefore the answer is tan theta. Again, if this was an exam, I would just substitute in a random angle, maybe multiple times. So just choose 2 or 3 different random angles just to make sure, and see which one it equals to. You can put it in all of these choices and see which is the one that equals, and you'll find that it's tan theta that will equal to the question. Okay, number 3. Cot squared theta plus 1 is equal to what? Again, I noticed this squared, so cot squared theta plus 1. Let's see if it's any trig identities. There we go. Cot squared theta plus 1 is equal to cosec squared theta. cosec squared theta. And that is 1 on sine squared theta. Let me see what's available. Okay, B, 1 over sine squared theta. Again, let's do our checking. Let's say that theta is 72 degrees again. And let's put it in the question first. 1.105578 ... And now we put it in the answer, which is 1 on sine squared theta is 1.1055728. Yep, all good. That was a nice short one. Let's go on to 4. 1 minus cos theta over 1 plus cos theta is equal to what? I am going to multiply this by 1 minus cos theta on 1 minus cos theta. And the reason I'm doing that is because if I multiply 1 plus cos theta with 1 minus cos theta, I'm going to get a difference of 2 squares, which is, it'll just become 1 minus cos squared theta, and I know that that's probably a trig identity. In the top, I'm going to get 1 minus 2 cos theta plus cos squared theta. Alright, let me just check that. 1 times 1. 1 times minus cos is minus cos, that's minus 2 cos, and then plus cos squared theta. Yep. Okay. 1 minus cos squared theta I know is sine squared theta. There you go. And the top will be the same. Okay. Now, you're probably wondering, why am I going in this direction? I can see, just from the answers that we are given, there's a cosec and a cot in every single one of these, and they're all squared. Now, I've got some squares. Cosec is 1 over sine, and I have a sine at the bottom, and I've got this 1 here, and sine over there. I also see that cot is the inverse of tan, so that's a cos on sine. And I have a cos up here and a sine down here, which are both squared, which is good because I need them to be squared. Now, because I've been doing this for so long and so many times, I've had a lot of practice to be able to spot that that this is actually the expansion of B. It's not C. I'll show you. Hold on. So, I'm going to split up these fractions to become 3 fractions. I'm going to have 1 on sine squared theta minus 2 cos theta on sine squared theta plus cos squared theta on sine squared theta. Okay, how did I do that? And why can I do that? And is it correct to do that? All very good questions. The reason why I can split these is because they all have the same denominator. So if you combine all of these fractions, it will turn into the line above, because all the denominators are sine squared theta. And then if you just do 1 minus 2 cos theta plus cos squared theta, you're going to have the line above. Therefore, these two lines are the same. They're equal. That's why we have an equal sign. We're saying that nothing has changed. We're just writing them differently. Okay. Now, why did I split them up? Because 1 over sine squared theta is cosec squared theta, right? And it's one of the terms in our answer, cosec squared theta. This one, I'm going to split it even further for a reason. One moment and it'll all be clear. So I'm gonna split it like this. 2 times cos on sine times 1 on sine. If you times them all together, you're gonna get that again. Plus, this last one is cot squared theta. So we have our cosec squared theta and our cot squared theta. Plus we have this middle value over here. So we can rule out option C. It's not C because we have an extra value in the middle. Now what is this? Why did I split it into that? Because now it takes a really good eye to be able to spot this, because this is cosec, no it's not, it is cot theta, this is cosec theta, right? So we have cosec theta and cot theta, and this is actually the expansion of cosec theta minus cot theta all squared. It's actually the expansion of B. To prove that, so let's say we have cosec theta minus cot theta times cosec theta minus cot theta. When you multiply it out, you have cosec theta times cosec theta, which is cosec squared theta. Then you have minus cot theta, then you have cosec theta times minus cot theta, which is minus cot theta cosec theta. Then you have minus cot theta times cosec theta, which is minus cot theta cosec theta. Then you have minus cot theta times minus cot theta, which is positive cot squared theta. And minus cot theta cosec theta minus cot theta cosec theta is minus 2 cot theta cosec theta. So therefore, if you expand this, you are going to get this. Now, for someone new or struggling in trig, you are not necessarily going to be able to spot that. It's just because I've had so much experience and I've done this so many times and I've seen the expansion of quadratic so many times that I can spot from here. This is why I did all that crazy things before. It's because I know that there's a squared at the front here and another squared at the back. So the middle is going to be 2 times the one at the front and the one at the back. So 2 times cosec theta times cot theta. And I saw it in here. I saw that I could get cosec theta and cot theta from this. And there's a 2. That's also a very indicative sign that it's the middle value of the expansion of a quadratic. However, not to scare you off, if you cannot see it in the algebraic way, again, since this is a multiple choice, all you need to do is substitute in a value for theta and see which one equals. So let's do that. So our theta again is 72 degrees. Let's put it in the question first. So we have 1 minus cos 72 over 1 plus cos 72 degrees. And we've got 0.527864 ... And now we put it in the answer and we chose B. 1 over sine 72 degrees minus 1 over tan 72 degrees all squared. 0.527864 ... There you go. Question 6. Cos theta on minus 1 plus sine theta plus 2 sec theta is equal to what? What I want to do first is to combine these two terms. So first of all, I'm going to change this to become 2 over cos theta, just because I like working with sine and cos rather than cosec and stuff. And if we look at the answers, it's all in sine and cos only, so I'm going to change that to cos. Now I want to combine these two, which means I have to multiply the first one with cos theta on cos theta, and I want to multiply this one by -1 plus sine theta on -1 plus sine theta. And we're going to get cos squared theta on cos theta outside of -1 plus sine theta, plus, I'm going to expand this, so it's going to be -2 plus 2 sine theta on cos theta outside of -1 plus sine theta. Now that we have the same denominator, I can combine the two. So it's all over cos theta outside of -1 plus sine theta. The top is cos squared theta minus 2 plus 2 sine theta. There's a squared again, which means there's probably a trig property, and I know that cos squared theta minus 1 is sine squared theta, so I'm going to split that up. Instead of it being minus 2, I'm going to make it minus 1 over here, and then minus another one over there. I'm just splitting up the minus 2. So again, together they'll still be minus 2 there, but I'm splitting them up. But now I can change this to become sine squared theta plus 2 sine theta minus 1 over cos theta minus 1 plus sine theta. This is, again, it looks like the expansion of a quadratic, but the problem is this minus 1. I need it to be positive 1, and I need that to be negative. But I need that to be positive. Hang on a second. Let me just check something. Sine squared theta plus cos squared theta. Oh, right. Okay, so this is negative sine squared theta, which is exactly what I need. Yeah, that's right, because cos squared theta minus 1 is going to equal to negative sine squared theta. I see. That makes sense now. Okay, everything is working out. So this is going to equal, I'm going to take the negative out, -1 factor out of this numerator, so that I can have this is a quadratic. I'm going to leave that the same. Okay, I'll show you what I mean. This bracket here is actually the expansion of sine theta minus 1 squared. If you expand this out, you're going to get sine squared theta minus 2 sine theta plus 1 over the same thing. I can rewrite this as sine theta minus 1. So now we have a common factor of sine theta minus 1. Therefore, it is sine theta minus 1 on cos theta. Do we have that? Oh no, why don't we have that? Okay, it seems we're not finished because it's none of these. So I'm just going to keep going and playing around with it. I substituted theta as 72 degrees and turns out A is the right one. So now let's try and get there. How do we get to this? I'm just going to clear some space. So we have 1 minus sine theta on cos theta. And we need it to get here. Firstly, I want a cos on top. So I'm going to multiply by cos theta on cos theta. That's going to get me cos theta outside of 1 minus sine theta all over cos squared theta. Cos squared theta is 1 minus sine squared theta. Like that. And 1 minus sine squared theta is a difference of two squares. So I can write that as 1 minus sine theta and 1 times 1 plus sine theta. And then that common factor cross us out with that common factor, and we have the answer. We have cos theta over 1 plus sine theta. And that is A. Question 7. If tan theta is 1 over root 2, then the value of the expression of this is equal to 1/10, 2/10, 3/10 of 7/10. We know that tan theta is opposite over adjacent, right? So if we have a right angle triangle and we have theta as, let's say, here, then tan theta is opposite over adjacent, which is 1 on root 2. Then the hypotenuse, I'm just going to find that now because I think we need it, is going to be the square root of 1 squared plus root 2 squared, which is 2, which is root 3. Find the value of the expression of this. Alright, so cosec squared theta is 1 on sine squared theta minus sec squared is 1 over cos squared theta all over 1 over sine squared theta plus 1 over tan squared theta. It's a lot of fractions going on, but it's okay. I don't like it. Let's start again. Instead of doing that, because that's just way too many fractions going on, I'm just going to go straight to the source. So cosec, we know, is the inverse of sine. Sine would be opposite over a hypotenuse, right? So then cosec would be hypotenuse over opposite. So that would be root 3 on 1 all squared, because it's squared, minus sec is the inverse of cos, which is adjacent over hypotenuse. So now it is hypotenuse over adjacent all squared over cosec, the same thing again, and cot would be adjacent over opposite. So it is adjacent over opposite all squared. Now we just have to figure that out. So this is just root 3. Root 3 squared is 3 minus, this will just be 3 over 2 all over 3 squared, root 3 squared is 3 plus root 2 squared is just 2. So that's going to become so that's going to be over 5. And that is going to be 6 on 2 minus 3 on 2. So it's just 3 on 2. And that is 3 on 2 divided by 5, right? So this is 3 on 2 times by a fifth. Therefore, it's 3/10. Let's check it. We always find a way to check this. So if you couldn't figure it out this way, what's another way that you could have done this? Again, let's put, we can't actually substitute whatever angle we want into here anymore, because we know that tan of the angle is 1 on root 2. So we have to find the angle. The angle would be arctan of 1 on root 2 is equal to, the angle is actually 35 degrees, 15 minutes and 51.8 seconds. So we have to substitute this value for theta into this fraction here. Let's do it. Okay, so we start off with a fraction. And we should get 0.3 because that's 3/10. Hey, we got 3/10. There you go. Question 8. Cot of angle A is equal to B on A, where A and B are real numbers. The value of sine squared A is equal to which one? So again, this looks like a triangular type of question. I mean, every trig is a triangular type of question, but this one, you have to actually draw it out. So let's just say this is angle A. Cot means it is the inverse of tan, so that would be adjacent over opposite. So the adjacent would be B, and the opposite would be A. That's an A, not a 9. Let's just fix that up. The value of sine squared alpha, sine squared A is equal to what? So sine would be opposite over hypotenuse. We need to find the hypotenuse. Hypotenuse would be the square root of A squared plus B squared. Sine A would be opposite over hypotenuse. So sine squared A would be this squared, would just be A squared over A squared plus B squared, which will be B. Alright, I don't think there's a way you can substitute in for this one, but it's a relatively short working out. So if you can think of another way, again, put it in the comment, it'll help everybody. We're on to the second page. How exciting. Let's go to question 9. A tree is broken by the wind. The top struck the ground at an angle of 30 degrees and at a distance of 30 meters from the root. Then the whole height of the tree is what? Very cryptic, this question. It's so unclear, isn't it? For example, like, what kind of tree is it? Did it grow perpendicularly from the ground? I mean, we have to assume so many things. Let's say our tree did grow perpendicularly from the ground. So that is a 90-degree angle over there. It broke and it fell 30. The top struck the ground at an angle of 30 degrees. So it's this one, not that one, right? If I'm getting this right. The trick to these questions is to draw the right triangle. That's pretty much it. If you draw this wrong, then everything else will be wrong. At a distance of 30 meters from the root. So this is 30 meters. The top struck the ground at an angle of 30 degrees. Yeah, I'm pretty sure it's this angle here. The whole height of the tree. So I'm going to call this O because it's opposite that angle, and I'm going to call this H because it's the hypotenuse. The height of the tree would be O plus H. So we have, let's find the opposite first. It's usually the easiest one. That's opposite over adjacent, so that's tan 30 degrees. Tan 30 degrees, what is that? I could never remember. Tan 30 degrees. Root 3 on 3. So it's root 3 on 3, which is also equal to O over 30. That looks like a 0, isn't it? I don't like it. Anyway, it's not a 0, it's an O. No, I don't like it. Let's make it a B. Let's make it a B, just so that it's clearer. Alright. If they're both the same, then we can work out B. B would just equal 30 root 3 on 3, which is 10 root 3 meters. So that's B over there, it's 10 root 3 meters. H is going to be adjacent over hypotenuse, so that is cos 30 degrees, which is root 3 on 2, I believe, which is also equal to 30 on H, adjacent over hypotenuse. So H is going to be, if I times both sides by H, and I times both sides by 2, and H is going to be 60 on root 3. Therefore, the height of the tree, I've run out of room, just gonna go over here. Height of the tree is gonna equal 10 root 3 plus 60 over root 3. Okay, let's make it into one term instead of two. So I'm going to times 10 root 3 by root 3 on root 3. So that's going to be 10 times 3 on root 3 plus 60 on root 3. It's going to be 90 on root 3. Do we have that? Oh yes, it's A, 90 on root 3 meters. Meters. So let's see what number that actually is. 90 divided by root 3 equals, okay, 51 meters, 52 almost. Let's check the other answers. 30 times root 3. So 30 times root 3 equals 51. Wait, what did we get before? 90 divided by root 3. 51. They're the same. Hang on a minute. Hang on a minute. If I times this by root 3 on root 3, it's gonna be 90 root 3 on 3, which is 30 root 3. Oh my gosh, what happened? 30 root 3. They're the same. They're the same. Hang on. What is going on here? 10 root 3 just sounds too short. So if you have 10 times root 3, it's too short. It can't be. So we've got two correct answers. That's odd. Because they're essentially the same thing. Right? Let me just quadruple check that. 90 divided by root 3 is 30 root 3. So they have two of the same. So you had a 50-50 chance for this question. Anyway, that's very odd. Let's move on. Question 10. If tan theta is 12 on 5, find the value of sine theta minus cos theta. So this again is just draw a triangle and make sure you get it right. So tan is opposite. Oh, the theta probably would be here then because it's quite large for the opposite side compared to the adjacent. Opposite 12 over adjacent, which is 5. Now that looks better. This is 12, that's 5. Then find the value of sine theta minus cos theta. So sine theta is going to be opposite over, hypotenuse. Let's find the hypotenuse. Hypotenuse would be square root of 5 squared plus 12 squared, which is 13. Oh, that's nice. So opposite over hypotenuse. Cos theta would be adjacent over hypotenuse. What's the question? Sine minus cos. So sine theta minus cos theta is going to equal 12 over 13 minus 5 over 13, which is 7/13. There you go. Is there a way to check this? Yes, there is. So let's check it. If there's a way to check, I always check because I don't have the answer sheet for this. So I'm going to do arctan of 12 over 5. So that is actually the angle. That theta there is 67 degrees, 22 minutes and 48.49 seconds. And then we just go sine answer minus cos answer equals, and we should get 7/13. There we go. Nice. Moving on. 11. If sine theta plus cos theta over sine theta minus cos theta is 3, then the value of sine theta to the power 4 minus cos theta to the power 4 is what? I'm going to times both sides by sine theta minus cos theta. So we're going to have sine theta plus cos theta equals 3 outside of sine theta minus cos theta. Just so I don't have a fraction anymore. That's going to equal 3 sine theta minus 3 cos theta. I'm gonna minus both sides by sine theta. So cos theta equals 2 sine theta minus 3 cos theta. Then plus both sides by 3 cos theta. So I'm going to have 4 cos theta equals 2 sine theta. Divide both sides by 2. 2 cos theta equals sine theta. Then we divide by cos. So we're going to have 2 equals sine theta on cos theta. And that is tan theta equals 2. Alright, now what? Since tan theta equals 2, we can find the value of theta. I wonder if that's what they want. Or we can draw a triangle. Oh, let's draw a triangle first. Tan is opposite over adjacent. 2 is the same as 2 over 1. So it's opposite over adjacent. This would be root 5. 2 squared plus 1 squared is 5. So it's the square root of 5. Now we can do the other thing. What is it? Sine. So sine theta is equal to opposite over adjacent hypotenuse. cos theta is going to be equal to 1 on root 5, adjacent over hypotenuse. Sine theta to the power of 4 is just 2 on root 5 to the power of 4. And similarly, the same for the cos counterpart. And that's going to be (16 on 25). And that's going to be 1 on 25. Therefore, if you add them, are we adding? No, we're minusing. If you minus them, it's going to be 15 on 25, which is going to be 3 on 5. Do we have 3 on 5? Yes, we do. Okay, now we can try do the other method. So when we got up to here, where tan theta equals 2, we can actually find out what theta is. Shift tan 2 equals. So that's the angle. And we just substitute it into here and see if we get 3/5. So sine answer to the power of 4 minus cos answer to the power of 4, equals 3/5. There you go. I found question 12 quite confusing. And again, I don't have the answer sheet. So I'm just doing the best I can with what I have. You'll find out soon enough why it confused me so much. So question is, if theta is an acute angle and tan theta plus cot theta equals 2, then the value of tan to the power of n plus cot to the power of n is always less than 1, 2, 3, or 4. I started off with graphing theta being an acute angle, which means that it has to be between 0 and 90 degrees, right? Tan graph goes like this. That's y, that's theta. And the cot graph, I'm going to change. It's going to go like this. That's the cot graph. The only time where tan theta plus cot theta equals 2 is when theta is 45 degrees, because tan 45 degrees is 1 and cot 45 degrees will also be 1. Any more or less than that, when you add them, it's not going to be 2. So let me show you. Let's say that theta is 44 degrees, and then when theta is 46 degrees. And we'll also add in when it's 10 degrees, and let's say when it's 72 degrees, our favorite number. So at 44 degrees, which is slightly less than 45, we're going to get with tan 44 degrees is gonna be slightly less than 1, so 0.965. Cot 44 degrees is 1.03553. Oh, it does kind of look like it would equal to 2, but I should have just done it from the get-go. So tan 44 plus cot 44 is equal to slightly more than 2. So this does not equal to 2 when you add them together. Okay, because it's more than 2. And you'll find that if you do 46 degrees, it's not going to be 2 either. Let's see what it is. 46. It's slightly more than 2. So when you add them, this is also not going to equal to 2. We needed it to equal to, it doesn't say greater than or less than, it's tan theta plus cot theta equals exactly 2. Let's continue with 10 degrees. It's way more than 2. And if we do our 72 degrees, it is not 2 either. So the only time where these two graphs would equal 2 is when theta is 45 degrees. That's it. So when it says then the value of tan theta to the power of n plus cot theta to the power of n is always less than what? Well, tan 45 degrees to the power of whatever you want will still be 1, because tan 45 degrees is 1, and 1 to the power of whatever is always going to be 1. Similarly, cot of 45 degrees to the power of whatever will still be 1, which is 2. Now, the question is, it is always less than what? Well, it's not less than 2 because it is 2, but it's less than 3, and it is less than 4. So they're both correct. 2 is less than 3 and 2 is less than 4. I wonder if that's why there's 2 ticks for this question. C and D are both correct. If the question was, then the value of this is always equal to what? Then it would be 2. But it says always less than. Well, it's less than 3 and 4. Yeah, well that's my opinion. Let me know what you guys think. This one is quite confusing. Moving on. Question 13. The numeric value of cot 18 degrees outside of this mess is greater than what? I think this is just a straight calculator question. I don't see a point in trying to do this algebraically. I mean, you can, but I don't see a point. It'll take too long, so I'm just going to go straight to putting it all in the calculator. I actually tried this question 3 times. The first time I put it in the calculator, I got that number on the screen there. And then I had an inkling that that wasn't right, so I tried again. And then this is the 3rd time trying it, and the 2nd and 3rd time resulted in the same number. So I went with that one. Equals 1. Oh, there you go. Got it. So never mind about that. 1 is not greater than 1. Therefore, the answer is D. It's greater than 1 on root 3. We got there in the end. I only had to do it 3 times. This is what I was saying about being able to use the calculator correctly. I mean, I couldn't even trust myself. So I had to do it 3 times to confirm. Question 14. Last one. I'm not gonna lie, it took me so long to get this one. But since I've already pre-done it, it'll look really, really fast and simple now. But just so you know, I struggled with this one. Question is, if sec alpha, cosec alpha are roots of the equation of this quadratic, then what? it was just like, then what? Okay, we have to try and figure out what this question wants us to do. We know that it's about roots. We know it's a quadratic. And at first I thought maybe they want us to use the quadratic formula because that's to do with roots. But no, it turns out not really. What they want us to do is play around with the sum and the product of the roots. So we know that the sum of the roots, I'm using alpha as well. Ugh, that's yuck. But anyway, doesn't matter. The sum of the roots is minus b over a, and the product of the roots are c on a. Now minus b would be minus p. On a is 1, and then c is q on a. So the sum of the roots is negative p, and the product of the roots is q. Okay, we are also told that these are the roots. So the sum of the roots which we know is negative p, and then the product of the roots, oh my goodness, I should learn to write smaller, is q. And where did I go from here? I changed all these to become sine and cos because I don't like sec and cosec. So we have 1 on cos alpha plus 1 on sine alpha is equal to negative p. This is 1 on cos alpha times 1 on sine alpha is equal to q. I'm just gonna put a dividing line there. And so q is gonna equal 1 on sine alpha cos alpha. And that's that. This one, I'm gonna times this one by sine alpha on sine alpha. And I'm going to times this one by cos alpha on cos alpha. And what I'm going to get is sine alpha plus cos alpha all over sine alpha cos alpha. I kind of skipped a step, so I multiplied it and then I added the two fractions to become 1. And that's p. Now if you notice, q and p looks kind of similar in the denominator. I'm going to separate this fraction. This fraction is really 1 on sine alpha cos alpha multiplied by sine alpha plus cos alpha. Okay, and q is 1 on sine alpha cos alpha, so I can replace the whole of this with q. Okay, why did I do all of that? I wanted p and q to be in the same equation, because if you look at all the answers, we have p and q together. And before, it was that q was equal to this and p was equal to this. But since I want them both in the same equation, I found a way to substitute the q into where the p is. So now we have p and q in the same equation. Okay, this took me a while to figure out, but essentially, there's so many things squared here. Like pretty much everything in the answer has a square in it, and I don't have it. So I'm gonna square both sides, but before I do that, I believe I'm gonna bring the q over so it causes me less headache. So I have sine alpha plus cos alpha equals p on q, like that. Now I'm gonna make more space. Now I'm gonna square both sides. So I'm gonna have sine alpha plus cos alpha squared equals p squared on q squared. Squaring this will give me sine squared alpha plus 2 sine alpha cos alpha plus cos squared alpha equals p squared on q squared. Sine squared alpha plus cos squared alpha equals 1. So I have 2 sine alpha cos alpha plus 1 equals p squared on q squared. Okay, I'm just checking where I'm at now. Do we have anything close to anything here? Yes. 2 sine alpha cos alpha is actually sine 2 alpha. Plus 1 equals p squared on q squared. So that is either A or B, right? Yeah. You see it? You see it? I'm going to minus 1 to both sides, so I have the sine 2 alpha alone on this side. Sine 2 alpha is equal to p squared on q squared plus 1. I mean minus 1, sorry. Minus 1. And we can rewrite 1 as q squared on q squared. So now we can combine the two. So p squared minus q squared on q squared. And that is A. Let me see if that's what I got the first time around. P squared minus q squared all over q squared. Yes, A. That looked super easy and straightforward when I just did it just now, because I've already done it before and I have spent quite a long time on it before off camera. So don't feel bad if you needed to take the time to figure it out. So let me just maybe go over some of the key points. First, trying to figure out what the hell the question wanted us to do in the first place, because that took me a while. I was playing around with the quadratic formula for quite a bit, but then I realized the quadratic formula is troublesome because it has x equals minus b plus or minus, all of that. But it has the x, and I don't want x in my equation because there's no x anywhere. So I ruled out doing the quadratic formula because I don't want an extra variable. Second, took me a while, but I was like, oh, roots. There's the sum and the product of roots. So I did that, figured out that the sum of the roots is minus p, the product of the roots is q. We have the roots, we add them, that's minus p, we times them, and that's q. And then it's just a matter of playing around with the equation from then on and try to go towards one of the 4 answers that's given. After a certain point, that you like simplify it, and it comes to this point. And I realized that, first of all, I have a cause and there's no cause anywhere in the question. That's problematic. Secondly, the p and q are not squared, whereas all the p's and q's in the answers are all squared. So again, problematic. And I can't just get rid of the cos alpha, so I'm gonna square them and see how it goes. Like, I didn't know where it was gonna go or how it was going to turn out, but all I know was I needed the p and the q to be squared. So I squared both sides, and then once you've squared trig, there's usually trig properties that you can use, and sine squared alpha plus cos squared alpha is 1, so that's nice. And then turns out that 2 sine alpha cos alpha also has a property of sine 2 alpha. It's the same as sine 2 alpha. Now this is exciting because, first of all, I didn't know where that 2 alpha was coming from. Like, because before all we had was sine alpha, and suddenly there's sine 2 alpha. Where did that come from? And it turned out it came from here. So that's exciting. And secondly, we have all the squared ready to go. So all we needed to do was get sine 2 alpha on its own, and then we just kind of figure out what's on the right hand side, and it is A. I hope that helps. I spent a bit more time explaining that last one because I know that was a tricky one to do. If I made a mistake, If you have other ideas, please join in the fun and comment. For now, I'm off to do the other 2 sheets, so that will be coming up shortly. See you in the next video.